guys, so this video is about the solution of domain range paper that you are supposed to work. So I'm gonna work at the right hand side, and I already show you the left hand side on during the live session. So I remind you that the domain represent the possible values for the x variable, and the range represent the possible value for the y variable. Okay, so in other words, domain is also you can also say is the possible value for the input, and range is the possible values for the output. Okay, so if you look at example B, problem B on the right hand side, this is a discrete relation, because if you represent this on a graph, you're gonna get a bunch of dots, and if you want to go from one dot to another one, you need to jump, in the sense that you need to raise your pencil from the paper and move from one point to another one. That's how you know that this is discrete. So anytime you have a discrete relation, you are going to use curly brackets, and for the domain you just look at the input. Okay, the input is the first number is in parentheses. So we have a 5 twice, but you write only once, 5, and then we have a 2, and then we have a 6, and then we have a negative 6. It doesn't really matter the order you write this. Sometimes, we start from the smallest number, but it's not necessary. And then for the range, instead you look at the output, which is 3, negative 6, 1, and negative 7. If any number repeats, then you write this only once. So we have a 3, we have a negative 3, we have a negative 6, we have a 1, and we have a negative 7. Now the second question is this relation a function? In order to be a function, each input needs to match with exactly one output. But notice how 5 is repeating, which means that the same input, which is 5, is going to two different outputs. 5 is going to 3, 5 is going to negative 3. So this is not a function, this is instead a relation. Okay, so not a function. Is this discrete or continuous? We already said that it's going to be discrete. Alright, so let's go to the second one. Again, if you represent this on a graph, you are going to get a bunch of points. 5 and 1, for example, right? That's 1 point. 6 and 2, there will be another point. It's around here, right? And then 8 and 8, it's going to be around here. So we have 3 dots, right? So we know we have a discrete relation. Okay, so I can actually start from here. It's discrete. So domain, again, is, since it's discrete, we're going to use curly brackets, and the possible value for the domain are 5, 6, and 8. And for the range, you need to look at this right hand side. So we have 1, 2, and 8. That's called the mapping. Okay, this type of representation is called the mapping, which you list all the values of x here on the left side, all the value of y on the right hand side, and you use the segments to connect these values. So 1 and 2 is only the range. 8 is not part of the range, okay, because nothing goes into this 8. Okay, so this is not part of the range. So just 1 and 2. Is this a relation, or can we say is a function? So the question is does each input match with exactly one output? Yes, because 5 matches only with 1, 6 matches only with 2, 8 matches only with 2. So we have the same output here, right, for 2 different inputs, but each input goes into exactly one output. So yes, this is a function. Okay, alright, so let's go to the next one. So here we have a continuous relation. So when we write domain and range, we should write this in both interval notation and set notation. So we know it's continuous because if I want to go from one point to another one on the graph, I don't need to raise my pencil. I can just, keep my pencil on the paper. So we know it's continuous, okay? for the domain, since it's continuous, if you want to write this in interval notation, what we're going to do is we're going to start from the value, the smallest possible value of x, which is -2, the most left. And since it's an open dot and -2, I'm going to use round brackets, and then the largest possible value of x is +2. And we're going to use round brackets again because there are two open dots, okay? For the range, this is an interval notation. Now, just one moment, we're going to write in a set notation, but for right now, let's take a look at the range. The smallest possible value for y is 0, right? So if you go, as you go from bottom to top, you start from 0, and we don't have an open dot, so it's going to be closed at 0. And then the largest possible value of y is 4, so 4 is not included in our range, so we're going to use a round brackets because there are two open dots at 4. In set notation, so that's called interval notation. In set notation, which I'm going to write here, so set notation, what we write is this. We use curly brackets, even though it's continuous, so we write x, and then this bar means such that, so, and then we write an inequality, and since x is between -2 and 2, we're going to write like this, without the equal sign. Okay, so x greater than -2 and less than 2. So x is between -2 and 2. And then for the range, we go to y, a bar, which means such that, so these represent all the values of y, such that y is between 0 and 4, but 0 needs to be included, so we're going to put an equal sign at 0. Okay? Alright, so that's how you write domain and range in set notation. Now, is this a function? No, because it's not going to pass. Well, yes, it is a function. It's going to pass the vertical line test. In fact, if I draw a vertical line at any place on the graph, this vertical line is going to cross the graph only once, right? So yes, it is a function. Okay? Alright, so let's take a look at number 2, here below. So here we have domain, again, is 8, 7, -7, and then 1, and then 3, okay? And then for the range, we have -5, 2, 8, 3, and 5. Okay, so is this a relation or a function? Well, let's take a look. 8, we only have one 8, so 8 goes into, so this input is exactly one output, which is -5. 7 is only 2, -7 is only 8, 1 is only 3, 3 is only 5. So yes, it is a function. It's continuous or discrete? Well, it's a bunch of dots, right? If you represent on a graph, you get dots, so it's going to be discrete. For the same reason, number 4 is going to be discrete. So the domain is 6, and then, so we're going to start from 6, and there's this. And then we have a -5, -3, 2 and -6, and then for the range instead we have -4, 9, and then -6, 8, and -4. Well, we have -4 twice, so we're going to write only once. Okay? Is this a function? Well, let's see. 6 is only one input, -5 is only one, -3 only one, so each input appears only once, so yes, this is a function. Okay? Alright, so let's go to number 6. So domain is represented by these values, it's discrete, right? So we have 1, 4, 6, 7, 9. And the range is represented by these three values. We have an arrow for all those values. So we have 1, 2, and 5. Is this a function? Yes, each input goes into each output only once, so yes. And it's discrete because again we have a bunch of points. Number 8, we still have a discrete, right? Domain is going to be 0, 3, 4, 5. And the range, notice how the range is only going to represent it by these values, 1 and 8. Is this relation a function? Yes, because each input goes into exactly one output. It would not be a function if I had the two arrows, right? So for example, if 5, I have another arrow that points out here to the right, so it would not be a function in that case. But in this case it is, so it is a function. And then, if you look at number 10, is a continuous function in this case. So the domain is going to, so an interval notation, so I put here interval notation, and here I put set notation. So in interval notation, the lowest possible value for x is -4. We have two open dots and -4, so I'm going to put round brackets, and the largest value is -2, but it's close at -2, so I'm going to put the square brackets. For the range, the lowest value is -4, and the largest value is +4. We have two open dots, so we put open in set notation. We write for the domain all the x such that x is between -4 and -2, open at -4 and closed at -2. And for the range is all the values of y such that y is between -4 and 4. Open, so we don't put any equal sign. Is this a function? No. You won't pass the vertical line test. If you draw a vertical line, it will cross the graph twice. Okay? So no, it's a relation. It's only a relation. And then the last problem, which is number 12. Okay, so here for the domain, it's a little bit tricky. We know it's continuous, okay? But for the domain, the lowest possible value of x is -2, so we're going to put a square brackets and -2, and the largest is +2, so round bracket. And then in set notation, we're going to write this as x such that x is greater than or equal to -2 and less than 2. For the range, so we start from the lowest value of y, which is -4. So this can be a little bit ambiguous because we have both a closed dot and an open dot. So which one are we going to pick up? Well, by definition, range is the possible value for y, and -4 it is a possible value because it is closed here, right? Even though we have an open dot here, but it's still a possible value. So, in -4 we're going to put a closed square brackets, and then the largest possible value is 0, we're going to put a round bracket, okay? So when you have both a closed and an open, you always choose the closed. And then for in set notation, we have all the values of y such that y is between -4 and put an equal sign at -4 and then less than 0. And this relation is a function. It passes the vertical line test. If I draw a vertical line, it will always cross the graph once, no matter where I draw it.